So my first impression is to be more efficient, what we call more crop per drop. That is the increased irrigation efficiency, increased water management, increased nutrient management, application of fertilizers and pesticides, minimizing pesticides applications would be really important. At the field level, precision agriculture is something that's important. If we can do all of these combinations, I think we can meet the global needs and the food security concerns are going to be alleviated. GPS at the field scale, at the farm level, there may be isolated places where people are already having access to, but on a global scale, it depends on the national policies and the technology and the know-hows of these farmers. In western part of the world, I think they have these GPS systems already integrated into field scale crop production practices, but in other places, I think it will take some time. I think there are global level products that's available, national level forecast that's available, but at the farming level, I think we need to have some downscaling done at the modeling side. I mean, it doesn't have to be on a field by field basis, but for a region or a watershed scale, we have already the forecasting of temperature, for instance, above freezing conditions or precipitation conditions. We have those products. For instance, up to 2 months in the US for this climate forecast system, CFS V2 product that we have is very useful to understand how the temperature is going to change. And precipitation to some extent is accurate. On a global scale, we have the same product we call Global Forecast System, GFS. And integrated with some level of decision support systems at the local scale, we can have the sowing time and harvesting time for farmers. GeoGlum product that you saw, they have harvest forecast. In the same way, the ground conditions can also be forecast with CFS products at the national scale, and global scale we have GFS products. And these products are available for 9 months ahead of time, but they are not always accurate up to 9 months, but they are good for first 2 months. A combination of Landsat 7 and 8 would be a good starting place, but then you need to know exactly what type of crops that you have on the ground, what is the soil moisture condition, and how you can really adjust irrigation practices. These are the general framework that we can have from existing NASA data sets on not at the farm level, but at the scale of a landscape or a small unit, smaller than the watershed, but not at the farm level. You have some products that's already available that farmers can take advantage of. My sense is that human intelligence and decision-making points may not be really obtained with robots and remote sensing and sensors. A combination of sensors and robots with human inputs would be required. How are we managing the migration or the loss of workforce in agriculture? That's a big question. If you have the younger generation of people that can really take up all these challenges when it comes to integrating technology for farm practices, I think you're going to see reduced attrition in the sense I'm talking about loss of workforce. You might be able to minimize, and we need to guarantee the income for farmers. If that's a policy level discussion that they need to have, and governments need to think about, but if they have it, I think you can minimize the loss of workforce. Depends on the place that you're referring to. On a global scale, NASA programs have some of these products available, similar to what Dr. Garrick Gutman was talking about this morning. LC Luck page would be the first place to go link the data links or data sources through their website. You can download from NASA. But if you're talking about Kazakhstan, I think maybe you want to look at Ministry of Agriculture or other agencies that are going to handle the data sets for you. Certainly you need information from the local agencies. On a global scale, Landsat 30-meter resolution product, it's already available for previous years from NASA. This morning from Professor Chris Justice, GeoGlam is a new program that they're introducing, and I'm seeing that the technology is not there yet in terms of looking at information to improve agricultural conditions at the field scale, but they have come up with a plan to do that down the road. Maybe in the next 5 years or so, I see technology will come to that level. Until that time, I think a regional level information, it's not just remote sensing. You need to have social components associated with it. Hydrological modeling is to be also included to understand how current conditions are going to be understood, and then how that is changing in the future. For example, I do climate change research and how things are going to change in Kazakhstan. And for example, in one place you will have more precipitation, in another place you will have less precipitation. Temperature, same thing, you may have differences. So what kind of drought conditions, what kind of flooding problems that you will have, that will change by region. So you need to be understanding at that scale to make some decisions. And I think that's possible by combining models, data sets, and also field observations. That's a very good question, because I come from water use, water management type of research. For instance, if you want to know how much water you need to apply for irrigation in the field, you can use Landsat based water balance, energy balance type of analysis at 30-meter resolution, and come up with soil moisture conditions and evapotranspiration estimates, crop water requirements, and then that can be used to see how much water you should apply on the ground, whether it is surface or sprinkler or similar type of irrigation systems that you have in this country. If you want to conserve water, how much water you should apply. It doesn't have to be always supply driven. It can be also demand driven. It can be demand driven in the sense, when you have a sunny day, you have certain amount of requirement for crops to evapotranspire, and if you supply only the amount of water that's required, sometimes they call deficit irrigation. You don't have to really recharge the entire soil column. You could actually minimize your application of water, and your crop yield will not be affected. So you need to be kind of adjusting those conditions based on the soil type, based on the crop type, based on the hydrometeorological conditions. And water management is the #1 thing in my opinion. If we can do that well, food security concerns are greatly addressed. So for example, in the US, we are using flood irrigation, we use sprinkler, we use drip, depending on the type of crop. And we also have rain-fed agriculture. So for irrigation, and in other places, I am very familiar to South Asia and Southeast Asia, and of course, there is no exact decision made for how much water should be applied on the ground. If they have plenty of water, they actually use the entire amount, and that's not the right strategy. And again, it is different for different crops. For paddy, you need to have submergence. You need to have water, standing water, ponding water for the crops to be producing yield. But for other crops, you have a cycle, once in a week, once in 10 days, depending on the soil moisture conditions. We have 3 or 4 different types of major irrigation practices: surface, flood irrigation, and then drip irrigation and sprinkler irrigation. And now the new technology is deficit irrigation. And without losing the yield, if you can supply water however much is required for supporting the crop, people should really do that. That way you will conserve water. Certainly, satellite data can be useful for making decisions because we have, as we heard, coarse resolution, medium resolution, high resolution data sets. If you can combine them and if you can fuse these different types of satellite products, we can even go to a field scale level. I foresee in the next 5 years or so, you would see space-based measurements are going to be highly useful for making decisions, especially on crop yield, water management, and also looking at disease, for instance. In combination with drone technology, if you can really map the field, and then having precision agriculture at the canopy level, how much water should be applied, or how much nutrients should be applied, and how much pesticide should be applied, we can actually make significant progress and to address food security concerns. Of course, with salinity, your fertility of soil is changed. You have to reclaim the soil. Your production becomes less. In fact, your land gets degraded, so it becomes a big problem. So periodic soil testing and applying good quality water is really important. And of course, if you have high salinity already, I would think your application should be really careful enough not to make it worse. Depends on the system. In some places it is going to affect the environment, and again it is a big trade-off, between environment and ecology and agriculture. Agriculture by far is the largest consumer of water, freshwater resource on the planet as such. 70% of water that we have, freshwater supply, is used for agriculture, and the remaining is used for drinking water supply, municipal, industrial, commercial applications, and also for navigation and environmental flow conditions. Thinking about optimally using the water, it should be based on high resolution analysis at the field scale. In combination, you need to have good remote sensing data sets, you need to have good in situ data sets, and you also need to have good physical understanding of the system through models. If you combine all of these three things and optimally use water, you can have sustainable agriculture. Sustainable agriculture is possible, but careful planning and decision making is necessary.